Start. Okay, so I'd like to welcome everyone to the research session of the symposium. So this is the AI ML track. Again, my name is Hugh Wynn from Rowan University, and I'll be the moderator. And so today we're going to have 5 researchers, each give 15-minute talks on the research involving AI, ML, deep learning. And so let me just lay out some ground rules for the presenters before we start. And so again, the 15 minutes that you'll be given includes Q&A. And so then you're welcome to speak for the entire 15 minutes, or if you want to leave some time for Q&A, you can do that. I'll try to give you a 2-minute warning at the 13-minute mark. So there are no breaks here. So we're just going to go one talk right after the other, and we're going to try and end at 12:30, and we're the last session. So for those in the audience, if you like to ask a question, please post to the chat. And then if the talk ends early, then the presenter can try to answer verbally, or if the talk is over, then hopefully the presenter will answer through the chat to your questions. Okay, all right. Then why don't we go ahead and get started? So our first speaker today is Oliver Alvarado Rodriguez from the New Jersey Institute of Technology. And he's going to be speaking on large-scale graph analytics in Arkouda. So Oliver, it's all yours.
Sounds good. Let me share my screen. So let me start with an introduction. Hi, everyone. My name is Oliver Alvarado Rodriguez. I'm a computer science PhD student at New Jersey Institute of Technology. And I'm here today to present our research on large-scale graph analytics in Arkouda. Providing equal rights in data science is important to increase productivity. The question is, where do we begin? Well, first we need to take away some fear from tech terms such as high performance, parallel, or distributed computing that general data scientists may not be very familiar with. They are just tools that we can all use to increase the productivity of our data science workflows. Then we can take down some of the barriers that can make these tools seem daunting or unattainable. 2 of these are the interface barrier, which involves removing complicated and low-level parallel programming by replacing it with high-level interpreted languages, and the resource barrier, which involves avoiding having to directly utilize supercomputers or high-performance computers, and rather rely on connections from personal computers to supercomputers. Basically, how can we make our interfaces nicer to access powerful resources? Then we need to make the quick and snappy interactive analytics work well with large data sets, which is often referred to as large-scale analytics. The objective of this project is to help create a one-stop solution for non-HPC users who need to perform analytics on massive data sets. We can achieve this with a tool such as Arkouda. The main focus involves creating and implementing some of the data structures and algorithms to provide a vast array of tools that data scientists may use. The framework of implementation is Arkouda, and we are focused on the red circle part here for this project and presentation.
Oh my God.
Why Arkouda? Well, from a talk given by the original creator behind Arkouda, Mike Merrill, we want our data scientists to drive an F-22, sort of say, and execute large-scale code on powerful backends with simple front ends. From the other creator, Bill Roos, Arkouda is a trunk of sorts that can combine a Python front end with a Chapel backend, allowing Python packages to interact with Arkouda and process data in the powerful Chapel backend. You can implement packages and libraries at either end. The main environment setup is nice and simple. You have your user at the front end working with their file or Jupyter notebook and communicating through a ZMQ socket to access all the powerful code at the backend. The Python implementation involves a PD array class, relies on Python to reduce complexity, and can integrate with and use NumPy. This Chapel backend allows for a simple distributed object storage and can run on massively parallel processors, symmetric multiprocessors, clusters, or even a laptop. Chapel is a high-level language with C-comparable performance, great parallelism handling, great distributed array support.
Are you serious?
It's portable. You can get Arkouda from GitHub and take advantage of the Python front end and nice server backend. The links are provided here in this slide with the link to the original software, as well as a link to our implementation, which is this link down here. Arkouda allows us to perform large-scale graph analytics. Why do we use graphs? Well, the information they can abstract, such as social networks, can provide useful information for researchers from all domains. As graphs become huge, computing at a local laptop level becomes close to impossible. Therefore, data structures and algorithms are needed to handle massive data sets. Our contributions include an array-based data structure, a breadth-first search implementation, and a triangle counting implementation. Pictured here is our implemented data structure that is composed of 4 arrays for the directed case and 8 arrays for the undirected case. The edges are sorted, and the directed edge exists from the vertex source SRC array to the destination DST array. These arrays allow for a search complexity of constants big O of 1 time, as any of the n vertices can find its neighbors using the NEI and STR arrays. The undirected case has some additional reverse arrays to enable this constant time. The raw data is only stored at the back end. Let's look at the image on the right. Let's say we have one vertex index array, STR. At index 50, we have the value 1000. And another vertex index array, NEI, at index 50, we have the value 3. It means that for the given vertex 50, the edges starting with vertex 50 are stored in the edge index array starting at position 1000. And there are totally 3 such edges. If there is not any edge from vertex I, we will let STR at I be equal to -1 and NEI at I be equal to 0. In this way, we can directly search the neighbors of any given vertex. Graph sketches can be used to run analytics on a smaller version of a much bigger graph. The user can pick a shrink factor, which will generate a new graph that is 1f of the original graph. Multiple independent hash functions were utilized for 3 different partitions to generate better results. Each of these parts make up 1/3 of the 1f sketch. A regression model was then built from experimental results to predict the number of triangles in a graph. Here's an example of the BFS problem. You start at a source vertex and then return a depth array that shows at what level each of the following vertices are in comparison to the source vertex. So our input is a graph. Our source vertex is 0. We perform BFS. The green values are the depths. And our output is a depth array, in this case D. Each index of this D corresponds to a vertex, and each value is the depth of that vertex in relation to the source vertex. So index 0 represents node 0, which the depth from itself is obviously 0. Then index 1 represents vertex 1, and its depth is 4, and we count the edges. 1, 2, 3, 4. We're 4 away from the source vertex. Now we show how parallel BFS works. Each of the ovals can be visited at the same time by the same locale, since no information is needed to be known between the vertices in that oval. BFS is a good problem to tackle with parallel solutions due to its asynchronous nature. Pictured here is our BFS algorithm to generate the depth array at what depth each vertex is found compared to the starting vertex. It exploits Chapel's easy distributed and parallel computing language constructs that are shown in red to return the final depth array. Chapel provides a vast selection of data structures that can be used to store vertices at the current frontier during BFS execution. They include set, disbag, and domain, which were all compared to each other. BFS is usually useful for finding shortest paths, for psychodetection, and for other problems, which are all really good problems to tackle when you're dealing with graphs. To show the flexibility of Chapel, we compare the different data structures in Chapel to one another to show the speedup that can be obtained from specifically optimized data structures in code against just picking whatever the first data structure or code structure may be. As we see, our final optimized version is much better than all the other implementations pictured here. The Delaunay graph with 2 or 3 million edges only took 1 second to return the BFS depth array. The speedups are shown in the table on the right, with the optimized code running 8 times faster than the slowest. This shows that we can take advantage of Chapel to improve algorithm design productivity. Now pictured here is a general outline of a triangle counting problem. Each triangle is counted and the integer value of the number of triangles is returned. This is our input. Then we count the first triangle, the second, the third, the fourth, and the fifth. You can see that some to get the final triangle count 5. You can see that some triangles may share edges and nodes. A triangle counting algorithm needs to consider triangles that may share an edge and up to 2 vertices. So these triangles here both share an edge, and over here too. Shown here is our triangle counting algorithm that was developed, which works for either a full graph or a streamed graph. A graph stream, as we mentioned before, is a certain large graph shrunken down so the algorithm executes more quickly with minimal loss in accuracy when comparing predicted triangle counts to true triangle counts. Chapel's distributed constructs, pictured in red, were exploited as well to split up the work amongst locales and amongst the multi-cores in each locale to return a final triangle count. Triangle methods help to provide useful information about graphs, such as small communities, friendships, or collaboration networks of size 3 that may exist. Here are 2 graphs showing the most important triangle method results. The y-axis is a relative error of how far off the number of triangles counted were compared to the actual true count. The formula above were the regression models used to predict the triangle counts, where EH over here is the exact count of triangles from the head partition, EM from the mid partition, and ET from the tail partition. The A, B, and C were fitted dependent on the trained model. When graphs were shrunken down, the error stayed relatively low. The mean error stayed relatively low, under 5% for normally distributed graphs, and under 10% for power law graphs. And all the max values stayed within the 25% range. Here's a table showing the speed up that is acquired when a graph is shrunken down. These speed ups, some of them close to 30 times faster, yield very little losses in accuracy, as we saw in the previous slide. Sometimes they may have to be adjusted to minimize the loss. The largest graphs, LJ and YouTube, shown in red there, with 30 to 60 million edges each, had little losses in accuracy with huge speed ups in execution time. So you can see for LJ, the stream time took 397 seconds and the exact time was 6,937 seconds. 397 seconds is about 6-7 minutes, and 6,937 seconds is about 2 hours. So really shrinking it down by a large factor with minimal loss in accuracy helps to speed up execution time. In conclusion, Arkouda proves to be a useful tool to perform large-scale graph analytics with the ability to implement graph and other algorithms rather easily. It allows for a friendly user interface with a powerful supercomputing backend if necessary. Our plan for the research includes implementing more graph algorithms and optimizing them for parallel and distributed computer systems. We can also look at other problems of interest and switch over from specific large-scale graph analytics to just regular large-scale data analytics. And that's it for my presentation. I can take any questions now.
Thank you, Oliver.
No problem.
Thank you. Yeah, so we have a couple of minutes for maybe some quick questions. If there's any questions, please post to the chat. Okay, well, I don't see any questions, Oliver. And so thank you again.
No problem. Thank you.
Yep. So again, feel free to, for the audience, feel free to post any questions for Oliver if you think of something later. But thank you. So we're going to move on to our next talk. So if I get the next speaker ready, I'll introduce them. So, okay. So Shamoon, are you ready? Let me introduce you then.
Yep.
Okay. So our next speaker is Shamoon Siddiqui from Rowan University, and he's going to be speaking on the case against sentiment analysis for natural text. So Shamoon.
Thanks. Thank you everyone for coming, for attending. So my presentation is a little bit different. It's going to be a discussion more on the results that I've got and the case that I'm building against sentiment analysis. So just some background on what sentiment analysis actually is. Those that are familiar with artificial intelligence or natural language processing, Sentiment analysis is one field within NLP. Broadly speaking, sentiment analysis aims to take some input text, do some processing, use the classification system, and tell you, is it positive, is it negative? You could also use sentiment analysis to figure out tone. Is it serious? Is it sarcastic? Is it authoritative? Is it fictional? Well, maybe not fictional. So you can use sentiment analysis to try to assess some sentimentality of the text. The case that I'm arguing against is that sentiment analysis doesn't actually work when you have natural text. So let's talk about natural text. Natural text is any text that is not structured. One problem in sentiment analysis research is that the data sets are fairly common. People use the same IMDb, Amazon reviews, Twitter data sets that actually have a label. So a 5-star review is positive, a 1-star review is negative. That's what is called structured text. Natural text is anything that does not have an explicit label of sentiment. There's far more natural text than there is structured text. On the internet, in our ratings, in our Amazon reviews, Netflix reviews, whatever review system, we have a lot of structured text, but there's even more that's not that. And to show how big of a problem this actually is, you see here the number of papers about sentiment analysis has really just shot up. So in the past 20 years, it was not even fashionable to think about sentiment analysis. And now here we have, 5 years ago, we're at 7,000, which is the latest data that I could get. But I'm sure it's far beyond that as far as number of papers published per year, right? So this is, again, per year, we're getting this many papers about sentiment analysis. So it is an important problem. When it comes to just the colloquial understanding, right? So that was academic. This is a Google search trends. Here we have natural language processing starting 15 years ago, coming down a little bit, maybe a little bit of resurgence with iPhones and Siri and Google Assistants. But sentiment analysis over that same time period, no one was searching for it. Now it's even more searched for than natural language processing as a whole. So sentiment analysis, which is a part of NLP, is actually more popular than all of NLP, broadly speaking. So we've seen how big of a problem it actually is, and what's it used for? Everything. There are, okay. So financial firms are using sentiment to figure out if a stock's gonna go up or down. Brands are trying to see, do people like my brand? Do they not like my brand? Let's steer away from politics, but politicians and public figures are using sentiment to see, is my messaging well received or not well received? This one's really important right now, the sanitizing. There are attempts to sanitize text to free them from bias or hateful speech or profanity. But the problem is they rely on some sentiment to say this is in fact hateful, not hateful, biased, not biased, racist, not racist. So this is an increasing meta problem that we're beginning to face. Okay, so let's get into my actual work here. So that sets up the problem. Rather than me building my own sentiment analysis model and beating state of the art by 1%, 2%, I said, you know what, I'm not going to beat the big three. And in this world, the big three are Amazon, Google, and IBM. They've invested billions and billions and billions into their natural language processing models. They've got cloud services that anybody can use. And the assumption here, this may be a flawed assumption, is that those models are in fact state of the art when it comes to sentiment analysis. And I'm sure other fields within NLP as well. So just kind of a quick snapshot here. So Amazon, Microsoft, IBM, Google Cloud, just the web services alone make a lot, billions, right? And year-over-year growth is even more telling. It's going to continue to grow. So the data sets. So like I said before, the standard data sets are things like the IMDb data set, which gives you movie reviews and positive, negative, 5-star, 2-star, whatever. There's the Stanford Sentiment Tree Bank, which again, it's just sentences that have tags of positive, negative. Yelp, right? This restaurant was great, 5 stars. This restaurant sucked, 1 star. But it's not natural. So what I'm using is natural corpora, starting with State of the Union the corpus, which is every president's State of the Union, every year for the past 70, 80 years. The Gutenberg corpus, which is open source books, right? So most out of print books, out of copyright books are there. The web text corpus, which is crawled from the web, just random places, Firefox discussion forum, conversations over in your Pirates of the Caribbean script, personals, and on and on and on. The inaugural corpus, so 55 inaugural speeches from presidents. And this one's probably the largest, which is the Reuters corpus, which includes news articles from Reuters spanning, I want to say, about 20 to 30 years. And includes everything from politics, business, and on and on. So these are the natural text samples that I'm using. So the experiment's actually pretty simple. Let's take a piece of natural text. Let's see what vendor A, vendor B, vendor C say about it. Do they all say it's positive? Do two of them say it's positive? One says negative, and all the permutations, which there are 6 of, right? So the first permutation is they all agree. All 3 services, IBM, AWS, and Google, all agree that this text is indeed positive. Partial agreement, so maybe 2 out of the 3 agree that it's negative. Disagreement, so given that there are 4 sentiments that we're dealing with, positive, negative, neutral, or unknown, do they all fundamentally disagree? And then this is the different permutations of partial agreement. So AWS and Google agree, AWS and IBM, IBM and Google. For control, right, we need to establish that natural text is more in disagreement than structured text. So we're using those standard corpora of movie reviews and Twitter samples. So this is just some normalizing we do. Okay, now the fun stuff. So for our control data, we could see that both Twitter samples and movie reviews have complete agreement, let's call it 45% of the time. And at least 2 of the 3 agree 85% of the time. And there's very little disagreement, 10 to 15% of the time. With structured text, the picture is substantially different. As a whole, complete agreement, sorry, this is still structured, okay. With unstructured text, it's completely different. We have complete agreement almost never. So meaning if you use these 4 natural text sources that I used, the 3 big services almost never agree on the sentiment. Partial agreement does happen quite a bit, right? So anywhere between 50 and 70%, which by the way, is still less than the partial agreement for a control group. And disagreement happens a lot as well, anywhere between 30 and 50%, which is substantially more than the disagreement for our control group. So broadly speaking, this leads me to the conclusion that we cannot use sentiment analysis for unstructured natural text because it's fundamentally unfair to say that natural text is positive, is negative, generally speaking. Specific reviews and this and that can be, but as a whole, natural text cannot and should not be used to analyze sentiment on and therefore make decisions. So with that being said, I will pause here and see if there's any questions or comments. Can I open the chat? Okay, there's a chat here. Okay, yeah, so let's open the floor to questions. You can, I guess, type them out here, however it's gonna work. And I'm happy to answer or dig in a little bit more.
Okay, thank you, Shamoon. So yeah, if there's any questions for him, please type into the chat.
All right, well, thanks everyone. And thank you again for the organizers for putting this together.
Okay, great. Thank you, Shamoon. Yep. So our next speaker is Bahar Ashnai from William Paterson University. And she's going to be speaking on a study of nonprofit fundraising strategies. What drives nonprofit fundraising? So, Bahar.
Thank you. Welcome, everyone. I'm going to share the slides. If somebody's kind enough to let me know that you're actually seeing the slides.
We see it. Yes, we see it. Mm-hmm.
Okay, great. Thank you, Oliver, Shamoon, and really thank you to the organizers. I have been involved in the past in organizing such conferences, and I never underestimate the effort that is put to offering such a well-organized event. I'm presenting this paper on behalf of myself and my colleague, Saeed Shekari. We're both faculty members at Management, Marketing, and Professional Sales Department at the College of Business within William Paterson University. In this study, we're talking about a nonprofit fundraising and the strategies that can be used to drive nonprofit fundraising. Just a little bit about me and Dr. Shekari. I'm an associate professor at William Paterson University. I hold a PhD degree in the field of B2B marketing from the University of Manchester in England. My previous work, teaching and research, focuses on business to business, marketing, sales, and purchasing, and I'm interested in using mixed method, both qualitative and quantitative research methods in terms of teaching and research. Dr. Shekari has a PhD in business administration from the University of McMaster in Canada. He is interested in quantitative research, and he has worked and taught in areas of qualitative research within interorganizational relationships in B2B markets. A little bit of background with regard to our research projects. We are focusing on nonprofit organizations. They play a vital role in building healthy communities and contributing in economic stability and mobility and strengthening the communities. And our question is, how can we use a wide data sets within the IRS data sets that are widely available and inform how they can tackle one of their key challenges, which is their fundraising. Only looking at New Jersey, we have over 38,000 nonprofit organizations in New Jersey only. They work in a variety of sectors, from human services to education and art and culture. It was really interesting to hear when our keynote speaker was talking about the interesting case study tackling homelessness. I believe Tara Dawson McGuinness was addressing that interesting case, and really a lot of these nonprofit organizations tackle really serious and impactful missions and causes, such as food and shelter assistance, etc. And in the core of their activities is really their fundraising capabilities. We are looking into how we can put together an innovative theory-driven as well as data-driven approach and formulate a theory and test it with the data so that we inform how a nonprofit organization can achieve their fundraising goals and ultimately achieve their missions and improve the living conditions of the communities that they serve. We look at fundraising as a performance issue. We are looking into, firstly, what are the resources that nonprofit organizations need in order to achieve fundraising, and also what are the strategies and enablers that they can use to maximize and gain from those resources. And we are utilizing a vast science within sales and marketing and running a parity between sales and nonprofit fundraising, and arguing that a fit between the resources and strategies is the key to enable a nonprofit organization achieve their fundraising goals. In order to really first understand the challenges that nonprofit organizations face, we started with a set of qualitative data analysis. We interviewed 25 professionals and key decision makers within nonprofit organizations. We analyzed the data using content analysis, and just to show you some of the interesting results. First of all, the amount raised was the key measurement indicator as the performance of nonprofit organizations performance. A couple of interesting quotas that really was a reconfirmation of our conceptualization based on the parity between sales and fundraising are provided here. One of our respondents said, all of the sales techniques are needed for fundraising. Another respondent told us, fundraising is sales. You need to follow the process and set both ambitious and attainable goals. You are selling the opportunity to give. So the anecdotal evidence reconfirmed our model, which is based on resource-based view of firms, which is, I'm going to explain in a little bit more detail in our conceptual framework. So in terms of our resources, based on the resource-based view of firms, we're arguing that, first of all, the nonprofit organizations' fundraising outcomes is dependent on their fundraising staff. Resource-based view of firms argue that organizations need specialized and strategic resources to achieve distinctiveness and ultimately competitive advantage. Within the literature, it is also demonstrated that brand recognition and brand equity is also another key driver of fundraising. And finally, the cultivated external relationships really strengthens fundraising and helps fundraisers build those relationships and encourages the donors engage in their philanthropic commitments and engagements with the nonprofit organizations. So we looked at the resources. We are arguing that a lot of nonprofit organizations have very limited resources. So the question is, how can they utilize those resources in a way that they can maximize their gain in terms of fundraising? The first enabler is what process are they following? And this is very closely related to our understanding of sales and how we are running this parity between sales and fundraising. So the way that they're prospecting their donor prospects, how are they targeting those potential donors? How are they presenting their causes and their value propositions? And how do they actually persuade those potential donors to donate and ultimately achieve their fundraising goals? The second enabler is what kind of communication channel are they using? Are they going for online one-to-one interaction? Are they going for mass email? How are they using social media? So what is it that they're actually using, and is it a good fit with the resources that they have? And finally, we're arguing that, especially when it comes to one-on-one interaction, when trying to raise big donor amounts, their skills such as persuasion skills, prospecting, report building are really key in terms of enabling the staff achieve their fundraising goals. And with that conceptual development, we are defining a concept, the concept of adaptive fundraising, which argues that when the fundraising staff is engaging in a one-on-one interaction with the donors, to what extent they can alter their fundraising behavior based on the situation so that they can achieve their fundraising goals. And it is informed by a concept which is very well established within the literature of sales, which is the adaptive selling. And we propose the typology that ultimately nonprofit organizations are to follow one of these two key strategies. Are they going for increasing the number of donors or increasing the donor amount that they're raising? And the enablers, the processes, the communication channel, and the staff skill set has to be in line with their ultimate strategy. And that is where the science of sales and marketing can be very informative. As for instance, when we are targeting increasing the number of donors, that's where there is a lot of similarity with the science of business to consumer marketing. And when we are talking about approaching those donors that they are very likely to donate big amounts, it is more similar to business sales, and the skills and approaches that are used in that domain can be very helpful in the area of fundraising. For our conceptual framework, for our direct effects, we are arguing that the resources that we are introducing has a direct impact on fundraising, and then those enablers and strategies and the fit between the strategies and the resources will act as a moderator. So that's how we test our fit model. As I mentioned, a part of this study looks at the existing data sets from the IRS, and that will be used for testing our first proposition, which proposes that the number of fundraising staff is positively correlated to the amount of fund that is raised by nonprofit organization. In terms of the empirical data, we are going to use the IRS data. There are over 1 million entities in the US registered as nonprofit organizations. Their tax returns in the format of IRS Form 990 is publicly available. However, it is a combination of electronic submissions as well as PDF. That's our main resource for the data set. Our subsample will include a longitudinal data of 10,000 nonprofit organizations over 10 years, and each one of those forms includes 350 data fields that we're going to be able to use for testing our propositions. In addition to that, a part of the conceptual framework entails data that is not included in the IRS data and is not reported as a part of the tax return. So just a few examples, for instance, the adaptive fundraising, we have developed a measurement scale for measuring that construct that is informed by the existing scales. However, we have modified it to the context of nonprofit fundraising, and for testing the propositions that involve the data that are not within the IRS data set, we are planning on collecting data through online survey method. So to conclude, we are running the analogy between sales and fundraising. And this is going to open up really a door for utilizing a domain that has received a lot of attention. There are a lot of theoretical and data-driven insight about the science of sales and marketing, and it will open the door for utilizing this science and inform fundraising. We are proposing a fit model between resource and strategy, which will help fundraisers better use their limited resources and ultimately fulfill their goals and serve their communities that they're extremely passionate about. Obviously, the next step for our project is to conduct the empirical study, which is going to be the quantitative part of the project, and test the proposed framework. Thank you very much, and I will be happy to receive if there are any questions or comments.
Thank you, Bahar. I think we do have one question, and I guess there's still about a minute or two left in your talk. So I'm reading a question that says, is in your research look into the Form 990 database? I'm not quite sure what that means.
Absolutely, yes. So the Form 990 is the format that the IRS collects the data set, the tax returns from nonprofit organizations. A part of our model will use the data from Form 990, but there are some parts of the conceptual framework, particularly, for instance, this skills of nonprofit fundraising staff and some other constructs that are not captured by Form 990, so the data set will be complemented by survey data so that we are able to test the full model.
Okay, thank you. Well, I'm afraid we have to move on to the next talk, but thank you again, Bahar. I think there's another question. Maybe you could reply through the chat. Thank you again.
Thank you.
So I'm happy to introduce Alexsis Wintour from Lapin Limited. And she's going to be speaking on fostering trustworthy data sharing, establishing data foundations in practice. So Alexsis.
Yeah, okay. So thank you so much for inviting me to talk about this. Yes, I'm kind of probably doing something quite different. I think somebody else said that earlier, and I think that I'm in that category because really what I'm looking at is large-scale data sharing. So really, the question that we've been asking ourselves is, what would happen if we could share our data safely? Would we make better informed decisions that allow us to flourish as human beings and as communities? Would we be able to make smart cities smarter and to cure incurable diseases? So the inspiration for data foundations that I'm talking about today came really from considering this question, because we know that data wields colossal power, and it's an asset which never erodes and is being produced at an exponential rate. We create about 1.7 megabytes of data per second for every person on Earth, and we're sharing well, we actually analyze 0.5%, and we share even less than that. So it's this massive resource that seems to be there. It's using up energy. We're probably collecting a lot of the same amount of data, but actually really to build data-driven products and services which allow us to move forward it's really difficult if people aren't sharing data. So what is it that we can encourage them to do? And if they aren't sharing data, why should we do that? So we've seen a remarkable example of the enormous benefit from data sharing at a worldwide scale. If you could move to the next slide, I just want to talk about this. When the new coronavirus was first identified in China, it took scientists only a few days to sequence the genome. And by March 2020, the results were published worldwide for everyone to use. So this data provided essential clues about how the virus evolves, how it spreads, and how it's treated. In fact, the speedy publication gave the world an advantage in the race against the pathogen. And for example, it enabled vaccine testing to be brought forward. So this is an example of a rapid global action to a health-related problem that had never really happened before. And it included advanced collaboration and cooperation between the private sector, the governments, and even the regulators internationally. Could I have the next slide, please? So therefore, if we believe that data is knowledge, then it's reasonable to assert that knowledge should be shared. However, this comes with increased responsibility. So as more data sharing happens, this increases the likelihood of data misuse and harm, particularly if there's personally identifiable information within the data set. So privacy protection is in constant tension with data access, and this is about balancing risk. So if we agree that data should be shared, then the question now is, well, how do we do this responsibly? Could I have the next slide, please? So attempts to find legal, ethical, and repeatable mechanisms or structures to support data sharing have not yet succeeded, although different models are now emerging through data institutions. And these are organizations whose sole purpose is to govern data on behalf of others. The possible designs for these organizations is in really hot debate. This is a blooming topic, but some early good practices are now emerging and some consensus of opinion, such as that they should encourage more independent stewardship of data through oversight of how data processing takes place. They should advocate for transparent decisions that take place in the open, and they should support equal representation of all the stakeholders. So any model creating the opportunity for collective decision-making, which includes for a voice of the individual, will increase trust and therefore encourage and incentivize data sharing. Can I have the next slide, please? Data foundations build in trust by design. They do this by providing a legal and ethical repeatable framework. And we believe that they're a cost-effective structure in which to incentivize data providers to share more data and do so safely. Can I have the next slide, please? This is our working definition of a data foundation at present. And a key advantage of data foundations is that they leverage existing legislation and they build on established precedents. So the legal framework is particularly appealing in terms of the transparency, the structure, and the foundation status. All of these are really important when it comes to good data governance. In a data foundation, there's a two-layered structure which influences decision-making, the guardian and the council. And this creates independent oversight. To us, it appears that this is really difficult to replicate under any other corporate governance structure that we've seen to date. Can I have the next slide, please? There are three core roles in a data foundation within the functional structure. So you have the data provider and the data user, which both sit as council members. And then outside of that, the data guardian. Can I have the next slide, please? So in this model, the role of the guardian forms a critical element in providing the independent data steward, which is key for advanced and optimal data governance models. The role of the guardian is a unique requirement in the Channel Islands legislation and is particular and peculiar to these types of structures. In fact, we predict that in the future, all large-scale data sharing will advocate for the use of an independent data steward, just like the guardian within this structure. So protection of individual rights, independent oversight, costs, difficulty in making collective decisions, these are all named as to why data sharing just isn't happening at the moment. So how might these new governance models like data foundations help with this? Can I have the next slide? In our analysis, we believe that effective multi-party data sharing requires 6 fundamental components for good governance. Specifically, in the model for data foundations, we believe that these are key to facilitating trustworthy data sharing, and that the data foundations framework satisfies this. So you need a comprehensive rule book, which can be founded through the charter of the foundation and also in the rules and the regulations that have to be created. You have a trust enhancing technical and organizational structure. You have a well-regulated structure, which is accompanied by a stringent governance body, which can be established through the role of the guardian in the foundation, which I just talked about. You have an inclusive decision-making body, which can be set up by the council of the foundation, and a flexible membership can be facilitated through amendments to the charter of the foundation. In fact, in the decision-making body, you can actually represent individuals. So you can get their voice heard at the table along with all the other decision makers. Can I have the next slide, please? So I mentioned a little bit earlier that data foundations really build in trust by design. And this happens right from the start of their concept. These structures look beyond the minimum standards required in law. And actually, there are 7 universal design principles that unite all data foundations. It's not really time to go through each one of these, but you can see them here. But perhaps one of the most important to just highlight is that we consider all data to be relevant. So that's personal and non-personal data. This is because personal and non-personal data are not really binary concepts. Data shared, used, and reused as part of any data sharing initiative are likely to be personal data or become personal data, for example, through purpose of use, data linkage, or as a result of use. Go to the next slide, please. So creating data foundations in practice can be via 2 legal routes. The first is via a registered data foundation in the Channel Islands in Jersey, which is the one that I've mostly focused on today. But you can also do this through a functional data foundation, which is established through a legal structure outside of the islands. So the choice is really with the data sharing initiative as to perhaps the jurisdiction that they're in, how they're wanting to share the data, what's the best use for them of different structures. The advantage of a data foundation is that it's a legal entity and therefore it can pass due diligence and enter into contract for perhaps the use of infrastructure or for commercial reasons. Can I have the next slide? So this is really the steps that we've been taking. I work with the University of Southampton Web Science Institute, and I'm presenting on behalf of my colleagues, Professor Sophie Stalla-Bourdillon and Dr. Laura Carmichael, and we form a team which is looking at impact projects where there are significant changes being made to communities through focused and safe data sharing at a large scale involving multiple parties. So we really set about writing the code of conduct and then applying that to entities. And we're now working towards and choosing data sharing projects to really bring these to life. We absolutely love projects that start with, well, we're not making much progress because we cannot share data and they can't really use some of the well-rehearsed methods because they're just not suitable or they're too costly in order to move their projects along. Yeah, that's what we're currently doing. We would absolutely love to talk more about with anybody who has that particular problem or knows of a project with that particular problem. Can I have the next slide, please? So yes, I just wanted to say thank you very much for allowing me to be here and to present to all of you from my tiny island, but we think it's a big idea and I'd really be delighted to discuss this more with anybody. So this is my email address and please do get in touch.
So our last but not least, we have then Faraz Gurkis with the New Jersey Institute of Technology. He's going to be talking about assessing community preparedness to disasters through GIS quantification of the Community Intrinsic Resilience Index. Okay, for us.
So thank you. So we're going to present today basically a new index to quantify community resilience and the tool that we built to facilitate the way to compute that index using GIS quantification. So I'm a PhD candidate in computer science at NJIT, and I did this work as part of the Center for Natural Resources with Dr. Michel Bouffader, and with collaboration with Dr. Hani Nassif from Rutgers University and Dr. Elie Bouzid from Princeton University. So today I'm gonna go over some overview about resilience and the importance of quantifying it, and then the shortfall of the existing ones, and introduce our problem statement and what we're trying to achieve. And then I'm gonna go over the methodology behind our index, which we call Community Intrinsic Resilience Index, or CIRI for short. And then the GIS-based web platform that we developed. So today it is more evident the environmental impacts of climate change with the continuous rise of sea level and the increased intensity and severity of storms and droughts. Moreover, these impacts are predicted to be to rise as well more over the next century. So to face all of these challenges, community resilience concepts have emerged as a way to enhance community preparedness to disasters. So to define community resilience in a nutshell, it's the ability of a community to prepare for, respond to, and recover following a disruptive event. And in our case, we're interested in natural disaster as a disruptive event. So if you go into the literature or any previous work on resilience, you're gonna see a different definition. So in every work, you have a new definition for resilience. However, we compiled all these definitions to showcase the three main terms of resilience, which is prepare for, respond to, and recover. So quantifying community resilience or having a numerical index to represent this resilience is of utmost importance, because using said index, we can represent the degree to which a community is resilient. So it's not like this community is resilient or not, but to what level. And subsequently to locate the non-resilient locations in a state or in a county and the weak components that need to be enhanced. Moreover, having a numerical index will facilitate the way to integrate resilience within the decision-making process in terms of assessing resilience and running scenarios. So there are several indices out there that either tackle community resilience or even social vulnerability, which is sometimes being used with resilience as two interconnected term, but the index itself is also used as a resilience measure. So not to dwell into the details of each of these indices, a typical quantification approach followed by them is we select a set of resilience component or subcomponent, which we call community sector, for example. And then for each sector, we select the attributes that are shown to affect resilience and follow a set of processing steps and transformation steps to normalize the data. And most of these indices follow a ranking system where they rank these normalized values for each of attributes. And then the index within each subcomponent is the average of all these attributes. And subsequently, the resilience community overall is either the average or the sum of these sub-indices. So some shortfall of these indices, first, most of them target specific political boundaries. So they are bounded by the geographical area that they created to measure. So for example, some of them is only for to measure resilience at a county level or at a city level, or some of them only for census tract level. Moreover, they use different set of sectors or the resilience subcomponents. For example, not every one of them use infrastructure. No one of these indices uses energy sector, for example, and some indices are only focused on the financial characteristics of a community. Then the main disadvantage of these indices is that they are comparative of nature. So because they follow a ranking approach, using these indices, we can say that a community is more resilient than another community or less resilient than another, but there's no way of knowing whether this community is indeed resilient or not. Another disadvantage is that in general, within these indices, resilience does not depend on the stress level, which is not the case, because we can say a community might be resilient to a 50-year flood, but it might not be resilient to a 100-year flood. So an index should tackle this or should include this in the quantification approach. So for example, if we have this, what we call like typical resilience triangle under a normal functionality for a community, let's say 80% was a normal, and then a shock happened, let's say a 50-year storm. Then this decrease in functionality and then the time it takes to recover, this is what defines the resilience of a community. So for example, let's say here for a 50-year storm, this community was able to recover in this time. For a 100-year storm, the decrease in functionality was more evident and it took more time to recover, but at the end, it bounced back to normal or to the new normal, bounced forward. However, for example, if we have a 200-year storm and the shock in functionality was way more evident, the community might not be able to recover to what was the normal before. And here we say that this community might be resilient to 50-year or 100-year storm, but it's not for 200-year storm. So to take all of these dynamic variables into consideration, we created a new index called Community Intrinsic Resilience Index, or CIRI, which measures the community absolute level of resilience to natural disaster. And because we wanted CIRI to be an absolute metric, we reported as a percentage. So using CIRI, we can say that a community is 80% resilient or 50% resilient. As for the subcomponent of resilience or the community sectors, we chose 4 that are most critical within a community, which are transportation, energy, health, and socioeconomic. So to quantify CIRI, we followed a typical quantification approach where we select attributes within each of these sectors that are shown to affect resilience. However, then for each attribute, we introduced what we call a perfect score. So a perfect score for an attribute represents its value in a best case scenario. So for example, one attribute within the transportation sector was the road area to population. We found that a perfect score for that is 0.07 miles square per 1,000 population, for example. So these perfect scores as of now are based on logical argument, experts input, and some data analysis across the whole United States. And moreover, we didn't assume that each attribute affect resilience at the same level, so we introduced weights. And these weights are subjective, so using our platform, practitioners could easily change these weights as they see fit. By default, they are equal because basically these weights can be different from one community to another. So within the transportation sector, for example, we use the road area to population, road area to land, transit performance, which is a public transportation ranking system, and the household vehicles as attributes. Within the energy sector, we use the power distribution network, microgrids, and renewable energy. For health sector, we used hospital beds, practicing physicians, and health insurance. And finally, for the socioeconomic sector, we use the education, creative class, storm-ready communities, which are like people living in a storm-ready community, which is a communication program developed by the National Weather Services. And then the per capita income and per capita GDP. So all of these attributes for each sector are used based on previous literature and of course, logical arguments and experts' input. So to put all of these attributes together, a sector resilience is a weighted average of the percent value of attributes within. So for example, let's say that we have a number of hospital beds. Based on our analysis, we found that the perfect score is 4.8 beds per 1,000 population. And in a community A, for example, we have 3 beds per 100 population, so the percent value would be 62.5%. So we took all of these percent values and averaged them based on their weight in order to calculate each sector resilience. And then subsequently, CIRI, the Community Resilience Index, is a weighted average of each resilience sector. However, we multiplied this average by a penalty term. So we introduced what we call a penalty function, which basically captures the situation where one attribute, the decrease in one attribute, might shock the whole system. So for example, let's say assume in a flooding scenario where 80% of the roads were blocked, for example, people won't be able to arrive to hospitals. So the number of available beds or the number of available physicians might not be relevant in this case, and hence the whole system will be in a shock. So as dynamic values, we assign P equals to 1, so there's no penalty if all attributes were above their minimum values. 0.5 if only one attribute is below its minimum value, and 0.25 if 2 or more attributes are below their minimum values. So by default, of course, we didn't assume that every attribute is critical in terms of the penalty, and we have like the road area, power distribution network, hospital bed, practicing physicians, and per capita GDP as the main critical attributes. However, using our system, anyone can change these as they see fit, and the default threshold for each one of them is 20%. Again, these are examples, and anyone can change them within the tool. So to facilitate the process of computing and extracting data related to Siri, we created a GIS-based web platform based on the ArcGIS library to measure Siri for any geographical area on the map. So some of the program functionality, for example, Siri is not bounded by any political boundaries like the other NDCs. So using this, we can measure the resilience index for any city, for any county, for any place within a sub-city or an area that spans across multiple municipalities, for example. So we gave the user multiple selection methods. One is rectangular, like select any rectangular shape on the map or any polygon shape on the map. Or even if users want to measure directly the county or municipality, their resilience, they can do so by clicking on a county or in the township or the corresponding city. So for the data used within Siri, we pre-populated our database with data from public sources such as Census, Department of Economics, Department of Health, the health area services, and a set of GIS feature layers in order to speed up the process of computing Siri. And all of these data are stored at the census block group level. So basically, when a user selects an area, we see this area as a set of census block groups contained within, and we compute the resilience at each block group and then do the transformation to the whole area. The only attribute that is computed in real time is the road area, so in square miles, because we're using the GIS feature layer published by New Jersey GIS for road center lines, and they might change. So we put it as a real-time computation. Whenever a user selects an area, we're computing it, but it's a speedy process. So it's not slowing up the system. So to compute Siri, for example, we select any area. Let's say here in a test case, we select Newark as a test case, and then a small dashboard which will show quick summary of the area selected, and then the resilience information, like transportation resilience index, energy resilience index, health resilience index, and socioeconomic. And here it's, we should say that energy resilience for now, it's a placeholder because we couldn't get the data from energy companies. They're usually like very confidential with these data. But using our platform, users could easily input these data here, and we believe that state officials and county officials would have access to this data. So in here, any practitioner could change the attributes, the minimum value, the threshold for the penalty function, sector attributes, and the attribute values, sorry, the sector weights and the attribute values, and then recompute Siri. So for example, assume we need to run a scenario of flooding, and we know 80% of the roads will be blocked. We're gonna change the available road area per population and per land, and recompute Siri to basically compute the post-disaster resilience in order to check whether a community is resilient to this type of event or not. So the quick test case or test study.
Excuse me, for us, just 2
Yes.
minutes left.
Yeah. As a quick test case, we computed the resilience for each county within New Jersey and found that these counties range from 63% for Cumberland to 80% for Morris and Bergen County as the most resilient. So now we're currently in the process of extracting and compiling data for each state. This is now only for New Jersey. And we're going to introduce more sectors. Now the priority is for ecological sector. Moreover, we're collaborating with local and state agencies to calibrate the model, add new attributes, modify the perfect scores. And at the end, we're going to leverage machine learning and AI to first validate the model based on previous disasters. So we map resilience information to disaster outcomes within a community. And we're going to use resilience information and climate projections to analyze and forecast climate change effects on local communities. So this is a presentation. If you have any inquiries or more information, you can now ask them or send me an email to the fg92@njit. Thank you.
Thank you for us. All right, so this concludes our talks. I just want to make some closing remarks before we end for today. So first of all, I'd like to thank all the presenters for speaking. And so I think it shows that we have a diverse, active group of researchers, not just even in New Jersey, but around the world. And so I think this field, of AI, ML, it continues to grow. And I think we're seeing that it's attracting a lot of interest. And so I'm sure there'll be a lot of upcoming conferences by NJBDA that'll focus on that. Next up, I want to also thank the organizers for hosting the symposium, in particular the Princeton University for taking the lead. I'd like to also thank you, Wright, for helping out with this session today. And then lastly, I want to thank all the attendees. And so thank you for coming and listening. Please visit the NJBDA website for upcoming workshops. So not only do we have the symposium, but we also run workshops, career fairs, talks, and so forth. So please check it out. And so then we hope to see you at next year's symposium. And let's cross our fingers and let's hope that the pandemic will be over. We'll be back to normal and hopefully hosting an in-person symposium. So, okay, with that, I want to wish everyone then a great weekend. Okay, take care. Bye-bye.